Yeah, thank you very much. Nice to be here. It's my second EuroPython. Last year I was just as a visitor, and now this year I thought, let's tell something about the work we do at the Netherlands Forensic Institute. So the summary of my talk is basically this. I'm going to tell you about how we at the Netherlands Forensic Institute used open source Python software, that's why we're here, to help prevent murders in a major criminal case by training a deep learning model, language model I should say, using active learning. This is basically the structure of my talk. So let's just start at the top. What is the Netherlands Forensic Institute? Well, you might have guessed it's in the Netherlands. Actually, it's in The Hague, to be specific. This is the building, and if you were to go in through the entrance, you would see people like this. So the NFI, the Netherlands Forensic Institute, is basically the crime scene investigation, the CSI of the Netherlands. So if you go in, you would see people analyzing DNA samples, analyzing drugs, bullets, pistols, you name it. And actually, I'm from the digital department, so we have a big digital forensics department where we deal with hardware and software as well. And a very important detail, which is different in different countries, is that in the Netherlands, the NFI is not part of the police. So I'm not a police officer. I'm just a simple government employee. I work for the Ministry of Justice. And we have the Forensic Institute that is responsible for analyzing traces, evaluating evidence, on the request of police, or public prosecutors, or even lawyers at the defense in criminal cases. And what we do is we use our expertise, our subject matter expertise, to help that, and also to develop new techniques to help ensure justice in the Netherlands. So one of these new techniques, you might be familiar with this buzzword, data science. Well, I'm a data scientist, and I work in the NFI, so I call myself a forensic data scientist. This is what we do. We investigate, we use the newest methods in machine learning and in data science for the betterment of the Netherlands. So that's who I am, and that's who we are. So let's talk a bit about open source. At the NFI, we love open source. I put some of the packages we use, our favorites, and you can see it's basically mostly the data science stack and some specialized things. So we're very, very happy with that, and it works great. But there's a little bit of a problem, because when people like me say that, like we love open source, what we basically mean is we love using open source. Like, it's a really nice libraries, and yes, sometimes we run into a bug and we submit a bug report, or if you're very lucky, a patch. But we can do better, I think. We're trying to do better. Maybe you've seen these stickers around. This is a campaign, like an advertisement campaign, not by the government, by an organization, that says, like, if you use public money to build something, you should publicize the code, public code. Well, I work at the government. It's not that easy. Just anything you write, you can open source, but we can try better, right? So in the NFI, we, not too long ago, we made a GitHub page. Right now we have 23 followers, so I hope at the end of this talk, maybe we have some more. The link is here. I will put the link up at the end of the talk as well. And just to show you a few of the things we've put there. If you happen to own a Tesla is basically a computer on wheels. It has cameras, it has logs, and we have a package called Tesla Logs that does what you think it does. It parses and analyzes logs and puts it together with the video streams. So yeah, anyone here has a Tesla? Okay, so acquire a Tesla and then that's what we do. Like, sometimes we have a government expense, like we need a Tesla for this case. Okay, I need to go faster than this. We also put some data here. So these are some experiments that have been done by iPhones to analyze the data that comes out of the health app. And basically experiments like walking, running, sitting, what kind of data does the iPhone generate and what can you do with it? It's open source data. If you have a nice project, you can use this. Any statistician in the room? No? Okay, well, this is very nice. This is a likelihood ratio library if you're into Bayesian statistics, evaluation of evidence, and calculating and calibrating models, we have a library for that. It's called likely ratio library. And finally, a colleague of mine, he made confidence, has nothing to do with forensics. This is a library that makes it very easy to load configuration from YAMLs from your environment and use it in a nice and structured way in your Python programs. Okay, back on topic, because you came here for the murders, right? Yeah, I hope you can appreciate that I cannot tell you everything about the major criminal case, but I can tell you the highlights. So it is about Encrochat. Has anyone here ever heard of Encrochat? Ah, look, okay, quite a few people. Well, for the people who don't know, it is something that's called a cryptophone. There are many types of cryptophones. Encrochat is one of them. It is actually a phone and applications. According to Europol, it is widely used by organized crime groups, and I do mean like the serious organized crime groups that like deal in drugs and in murders. It was operational from somewhere in 2016 to 2020. So most of what I'm going to tell you is at the end of their operational life in 2020. And what they sold were modified Android and BlackBerry devices. You can buy them from Encrochat, the company. And you can only communicate between those Encrochat devices. They are like specialized devices to communicate in a secure and private way, which by itself is not illegal. The price is €1,000 for the phone and 1,500 euros per 6 months of subscription. Like you're paying a lot for your privacy. And you can imagine, in broad strokes, like these phones showed up around heavy crime, like suspects of murders, assassinations, stuff like that. So in a lot of places, a lot in the Netherlands, but also in Spain and Germany and the UK. And very complicated, long story short, the court ordered that the police could try to intercept the messages from this specific service for a limited time, because it was used so much for criminal purposes. And actually, these people, they sent a lot of messages, tens of millions of messages, and for a period of time, the police was able to have a live tap of that, like get in real time the messages that were sent. And this is where we come in, and this is where the data science comes in, because the court gives this rather broad permission and expects something in return. Like you are able to read these messages as the police. Some of them will discuss preparations of heavy crime, maybe that could hurt people. It's like, oh, if you have that, you have to make sure that you can act on that to protect people's lives if possible. So then they came with this question to us, like, which of these millions of messages discuss, yeah, we call them in Dutch liquidations. So I'm not talking about murders like crimes of passion, like I'm talking premeditated people of one gang assassinating another gang, these murders. And the problem is, and it's a bit weird to say it this way, but these are very rare. These messages that discuss these liquidations, that's a good thing. But we need to find them, and we would like to know fast. It's no use if we know that a murder is being prepared tomorrow and we know it a week from now. That doesn't help anyone. So us being the data science team, they came to us like, can you help with this? So let's go to the data science part. We have a low base rate, right? Like the base rate in your messages is like the messages that talk about the preparations of murders is very low. And let's take an assumption like 1 in 10,000. Yeah. I tried to put on a slide like what is that? So this is 10,000 times the word no. Well, actually not. There is one yes, but it's YS, so it doesn't break the pattern. So I think you have to be in the front row to be able to spot it. Can anyone spot it? No, I didn't think so. It's here. You have to trust me. Yes, so 10,000 is a lot. And now you just have no's, but you have to imagine each of these no's is a message, talking about something in context. If you have to read it, you have to read it, try to understand maybe the context, evaluate it. And yeah, it takes a long, long time to get to the yes, and this is simply not feasible to do by hand. The police is really not afraid to put a lot of manpower on things, but this is just too much. So I'm going to show you some examples And of course, they have to be fictionalized. I cannot show you the real examples. So, and they have to be in English, because I'm doing this talk in English. And of course, these messages were mostly in Dutch, what we're talking about. So there might be something lost in the double translation. But some examples, I'm going to read the first one. Like, bro, he went to visit him and gave that order. He's going to lure him, and then they will shoot him. And there is nothing cryptic about this, right? This is like stating the obvious. This is not unrealistic, because you remember these people, they were communicating under the assumption that they were completely safe. So they were talking completely in the open about criminal things. Other examples, like he has to disappear. I'm done with him, with disappear here misspelled. No worries, dude, he's going to put that nephew to sleep. This is something that is lost in translation, the nephew here, but yeah. Going to put someone to sleep basically means to kill them. And stuff you don't come up with, like, we'll torpedo the mascot. These are the types of messages that you get, and the task of the humans and of the data science analysis we're going to do is to create some model that is going to make the distinction between the two, like, are they talking about planned murders or not? Well, the contact length was in this service was typically between chat messages and email. They were using PGP under the hood, so it was kind of like an email service, but people send short messages. So it's not your typical chat message. Extensive use of slang, something we call street language with slang, criminal slang, certain subcultures. It's not your typical Wikipedia text, to put it mildly, which all our models are trained on. There's a lot of spelling and grammar mistakes. And one strategy, what you could do, like a baseline level, is like, okay, let's create a list of words that occur in these messages and just execute a search query, and then you will get some of the results. And the problems, yeah, it's quite obvious, but you will get too many false positives. So sleep will occur in like context that has nothing to do with murder. And false negatives, like I would not have thought to put the word torpedo on a list of keywords. So that's why we are going into the deep learning model. We want to use something that has a little bit more understanding of language that can understand the nuances in something. So let's go forensic data science. Basically, you can translate this to quite a simple data science task, right? This is a binary classification. You have a text, and you want to classify yes or no. This talks about a threat to life is what we call the general category. You can give it a score. And what you need is a suitable language model and labeled examples to train on. Well, it was 2020, so what language model did you think we used? Correct. It was the thing to use, and still is for many use cases. So for people who don't know BERT, it's a language model trained by Google that you can fine-tune to do certain tasks. It comes pre-trained on language, something that you could call language understanding, and you can use that in your fine-tuning. So for example, you would know that torpedo has something to do with like destroying, like it's a negative thing, even though you've never taught it that in the context of this task. So it looks like this. If you create a fine-tuned BERT, you can put a message in there, I'm going to kill him, and it's going to give you a score. I don't know if everyone can read it, but it's 98% threat to life and 2% not threat to life. This is the idea, simple binary classification. And you need a model to start with. Well, you can just get from Hugging Face models, you can get the BERT-based multilingual cased. Actually forgot how many languages this can do, but Dutch is one of them, so that's nice to use. Or you can go more specific. Specifically for Dutch, there is a model called Bertje, the BERT-based Dutch cased. That is a model specifically trained by University of Groningen to be trained on Dutch texts. So the model is quite easy, and if you want to, you can even fine-tune this model unsupervised on your type of data to get it even more understanding. So now we just need labels, right? We need labels. So we need to find some of the messages that discuss the preparation of murders, which are pretty rare, which was exactly the question I started with. Like we need labels, we need this wall of text, and we need to find the yeses. And the only thing is we need you don't need to have to analyze everything. You just need to get like a sample enough to train the model, but still, they're very rare. So that brings me to what we did, active learning loop. So what is active learning? Well, it is a loop. And what you do is you start with some small labeled set. You train your model, your bad model in this case, to be able to predict whether or not a message discusses a threat of life or not. And based on that first sample, it's going to learn something, but it's going to be not very good, but better than random. So what you do is you take the output of the model, you train the model for a bit, you run it over your whole data set, it gives scores to everything, and you can take those scores and use that as prioritization for labeling. Have humans look at the output of your model and see like, oh, this was wrong, this was correct, this was wrong, and generate more data. So you need a start. So you can start with just a keyword list. Like take some of the words, sleep, like I said, you can get some of the true labels you want to look for. And you add it by random, and if you want to bootstrap, you can just assume with a low base rate, if you take something random, it's going to be a negative sample. You might get unlucky once, but on average, it's good enough to start with. And then you have this set, you train your model, you have it output, and you have humans look at it and label it. Yes, no, correct. There's a problem with this strategy, and that is it's very easy to train yourself into a circle of only what the model knows. It will predict, give a high score, give to the labelers. The labeler will say yes, and now you need a strategy in active learning to combat that. And that's basically a strategy, a sampling strategy. And you can do very complex sampling strategies, but you can also do simple ones. So for the next loop, you can sample from your data set based on the scores. So let's highlight this one. It's like prediction. So the model thought that this message is a threat to life between 0.4 and 0.6. It's like, nah, I don't know, is basically the translation. So the model's not able to infer anything from these messages. So that would be a nice message to label, like tell her the truth, like, no, this is actually discussing threat to life, or this is not discussing threat to life. Now, you can do that with lower predictions, higher predictions. But what I think is most important in these kinds of contexts is you keep adding a subset of random sampling from your data set. And that gives you a sample from your data set. If your model like trains itself into a corner, it can get from that samples, it can get examples of things it's doing wrong or right. So let's look at some examples of what you have to label. Again, fictionalized and translated. So I have 3 examples here. Bro, you're totally right. We will get him. Is this a threat to life? It's actually not easy, right? Like it could be talking about football. Like they're going to have a football match. You have to imagine like people are chatting a lot on this service, and even though it's only Encrochat phones talking to other Encrochat phones, yeah, some of these communities are actually communities and talking about other things than planning murders. So this one, it's hard to say, but maybe from context you can get it. Got's my AK. I mean, yeah, is he going to use it tomorrow on someone or not? That's the question. It's like this is hard. This is a hard problem. And yes, his wife is going to die. That could be a direct threat, or someone could be sick, and just it can be a factual statement. So many more of these examples that make it hard. Labeling is harder than you think is my message, and no one ever talks about this as my experience in data science. It's like, you just acquire some labels, and then we're going to talk about the model and fine-tune the model, and what kind of, like, do you need dropout or not? Or like the labels are very important, you need to think about that. Luckily, we had some help. We had police domain experts that were available for labeling. So these people, police experts also know more of the slang, they know the context, and they can give a much better impression of what we're talking about than me as a forensic data scientist can. So this is some of the results. Like so you train this model in a loop. And what I highlighted here are some messages that have sleep in the content. we did modify them a bit, but you get the gist of it. So you can see that like there are sentences like, did they sleep over? Baru and Yiza, assuming these are names. Baru is the news because I really want to go to sleep. Like these have the keyword sleep that is used in Threat to Life, but they get a low score. Presumably the model learned the context of this. And then there are some other ones like Brothers, Tilo, I guess that's a person again, has put Baldy, I guess it's a bold person, to sleep, a lot of exclamation marks. So this is actually like someone got murdered yesterday, and like they are communicating about that, like someone got murdered. He has to sleep. First thing, they're going to hunt. Now he has to sleep. First thing, they're going to hunt tomorrow. This is also talking about preparation. But then the other one, that's maybe the smallest one, but it says, go to his house fast and get that phone. You keep that, because people who are only sleeping are no use to me. So that is actually not a threat to life. It's just, yeah, you're no use to me. But yeah, a model is never perfect, and this gets a somewhat higher score. That's not perfect. So it's not like 0.9, but it is, yeah, it is, a model is never perfect. So what you do, we've trained this model. We apply it to all the messages. You apply it live to the messages that stream in. And then you give it basically to the police. And you say like, okay, you can sort these messages by these scores. Maybe you have some other filters if you want to. And like, if you're going to read like these messages, investigate, maybe start here. Because these maybe will save someone's life. Precautions about active learning. Like I already said, I said most of this, but like keep always random sampling. Like any system that is like self-learning in production, always make sure there's some kind of random labeling going on that you can see its results in practice. Always validate your models. I guess everyone does that always. But this is not trivial for like lawyers, like that you keep like a data set outside and you validate on that. That is important. And like I said, high-scoring messages are read by humans. Make sure you get feedback on mixed signals. If investigations lead to messages that were not giving high scores by your model, make sure that feedback comes to you. And very important, like only humans decide on taking action. Like you would not want like this model to give like a high priority to someone's message and like to arrest that person or something. That's not something you do not want and do not ever want to make. So the results of what happened in this case, I'm going to go quickly because I'm running out of time. I want to have time for questions. This was a press release by the police a couple of months after the operation. Now, like hundreds of suspects arrested. There was 8,000 kilos of cocaine seized, dozens of firearms. There were 19 synthetic drug labs dismantled. They were like hiding in the Netherlands. And specifically on this topic, they said in the Netherlands alone, more than 3,000 signals that appear to be life-threatening have been processed in recent months. By always intervening in a timely manner, the police have prevented dozens of serious violent crime, including imminent kidnappings, extortions, assassinations, and torture. And this is no joke. They actually found like shipping containers rigged with like a dentist chair, like ready for torture. It's quite a famous scene. So it's very nice that they were able to prevent the use of that. Well, if you ask Europol 2 years later, they give you like numbers like over 6,000 arrests, like this case in general, right? The Encrochat case in general. 6,000 arrests, yes, almost €1 billion euros in funds. Well, you can look on the Europol website to see the numbers. Personal feedback that we got from the police is that without the model, we would have been overwhelmed by the number of false positives. And besides that, the model recognizes extra threat to life signals, so that is false negatives that we were able to get, that could not have been detected if we only would use word lists. So yeah, they were quite pleased. Yeah. And that is how we at the Netherlands Forensic Institute, you know the rest by now. Thank you.
Thank you, Edwin. It was a great talk. We have a lot of time for questions, so let's start.
Hello. So you talked about a live stream of messages that was fully encrypted by PGP. How did you manage to decrypt all those messages?
That's a good question. So I don't have this. I do have the slide. Wait, I'll show you the slide of the advertisement of because there are a lot of buzzwords here. This one, right? Yeah, it has AES, it has RSA, it has PGP. Yeah. So actually, I'm not part of the team who broke it. Like it's the police. But what you have to consider is these are services that build some kind of custom infrastructure to sell you a private service, and they claim to use all of these things. Right. And do they have weaknesses? I don't know. Like the official story, well, like in the media, they said in the press release, like the police hacked this service. So there was somewhere a weak link, and there were servers involved. That's all I know, basically.
So the keys were stored on the service?
Actually, I honestly don't know, but you can expect mistakes were made.
Hi, the talk was very interesting, thank you. I have two questions. So, does the police use models to track other platforms? And if Encrochat doesn't work anymore, what is the new Encrochat for crime organization?
Okay, two questions in one. Does the police, well, basically the slide is, I'm not the police, I honestly don't know. You should ask the police. What was the second question?
What is I mean, crime organizations still communicate in some ways, right? So what is the new Encrochat? How do you find that?
I'm not really into that world, so I don't know what is...
All right, thank you.
Like, what I know is that this goes in fashion, and every few years there is a new service, but I only hear about it when they get, like, cracked by the police, so I don't know what is currently... Like, maybe some open source things would be nice to use if you want privacy, just saying.
Hi, if I may. I was immediately thinking about with Europe being so open and even quite easy everyone being able to get into Europe from outside of Europe, but inside Schengen, you cannot expect the criminals to be nice and always speak just Dutch, right? So you have obvious bias that you're gonna remove like the Dutch gangs from the scene, and you make it easier for non-Dutch speaking gangs in Netherlands to thrive, no? This way.
I guess. This is a very big investigation. You saw the word Europol there. So, yeah, we always deal with the problem of multiple languages at the same time. And yeah, it's like you have to take precautions. You have to make sure your models are, like, basically you have goals, and you know, like, every machine learning model is going to have, like, blind spots, and yeah, you have to be aware of them and make sure, like, what is the effect of that, and what can you do with to combat that?
Thank you.
Hi, very nice talk. Is your life at risk?
I hope not.
Yeah, because Dutch criminals are quite famous for not really liking when someone interferes with a, let's say, cocaine business.
That's very true. That's of course, you take that into consideration before we publicly talk about what we talk about. What I can say is everything I told you has been in press releases. It's public information, like summarized by me for you with a little bit of data science detail. So, yeah, if I were a criminal, I would not start with me. Like you can see my answers to these questions. Like I don't know. So, yeah.
Right. But you're helping the police.
Hi, thank you for the talk. One of the blind spots that I was thinking about is code switching. So when criminals start to use sort of two languages but in the same sentences, is that something you came across, and how did you deal with that?
I don't know about purposeful code switching, but we have the problem, I called it street language or like heavy slang. Like there are many very interesting linguistic aspects of these messages that different subcultures, maybe different cultural backgrounds, different language backgrounds, and they all mash together, and that's what makes the data science on this challenging, that you cannot just take any model from that's trained on Wikipedia and expect good results. It is, yeah, but you can imagine in a case like this, like many different expertise come at play, including some linguistics expertise.
Thank you.
Sorry, we don't have time for more questions, so you can find Edwin in the code space.
Yeah. Yeah, you can come to me. Thank you.